experience in the construction industry, we came across inefficiencies to communicate data, structural attributes, and to succeed in precise results during the assessment of building assets. Therefore, we set as a mission to digitalize key functions of the construction industry with the use of robotics, thereby creating a process that is lean, efficient, safe, and cost-effective. IDA is a novel approach to the precision inspection of building assets using an autonomous UAV flying through tightly confined spaces, a task today significantly difficult and dangerous for humans. The main indoor areas that require high precision information include indoor application systems such as heat, ventilation, air conditioning, and elevator systems. The focus on IDA lies on the digitalization process of elevator shaft assessment in new installations, incorporating value for safe and highly adjustable elevator systems based on an end-to-end approach powered by autonomous aerial robots through a scan-to-beam method. The data collection missions are conducted with the autonomous UAV, gathering visual and spatial data, which are analyzed on a cloud platform to create the asset's digital twin. At the beginning of the project, the system was at the prototype level, using various commercial off-the-shelf solutions to demonstrate the concept. The main objectives of the project are, first of all, the reduction of the operational cost for indoor measurements by 65% compared to the manual process. Second, the increase of the safety degree to 100% by accessing an elevator shaft only from the lowest level compared to accessing every floor through the manual method. And third, the automation of a scan-to-beam method in order to generate the process and convert point clouds to accurately fit beam models. The decreasing duration of the measurement process using IDA and the creation of the S-built model is expected to reduce the need for multiple transfers to the project site. This reduction will contribute towards the European Union's net zero commitment, especially in densely populated areas. Furthermore, the autonomous inspection process will diminish any risk of procurement of equipment not compliant with the building specifications, allowing for accurate installation planning directly on the generated models. A major aspect of the solution's social impact pertains to the safety risks in project sites. Physical presence will no longer be required, resulting in a decrease in accidents and project sites. For job creation, due to the implementation of a digitalized workflow, the wide utilization of the IDA solution is expected to make the construction sector more inclusive and lead to the reskilling of mechanical engineers while creating new jobs for BIM engineers. The project was a great opportunity for two innovative companies, the Cinque and Vertliner, to come together with combined expertise from the construction sector and robotics in order to create and test an innovative approach by using the current robotic UAV equipped with numerous sensors for indoor navigation, data collection and analysis. This has been proved an efficient alternative technique to the manual process, allowing the creation of a digital replica of the elevator shaft as a building asset and enabling at the same time an end-to-end process starting from the digital quotation phase of the elevator installers and moving it into the generation of BIM model. On the other side, part of our future plans is to keep pushing and developing the tools that we have created, adding more and more features with advanced artificial intelligence and machine learning algorithms, continuous monitoring capabilities, and so on. We want to be able to offer our customer a holistic solution when it comes to engineering and operating autonomous systems in confined spaces within the construction industry.
In the Metabuilding project, a web tool has been developed in order to improve the visualization of the impact of climate change for designing and maintaining critical infrastructure. The web application, after logging in, gives to the user the possibility to choose between an Europe general view and a specific high-resolution view. In the first case, an aggregated European country view is shown. The user can explore how the distribution of extreme precipitation events can change across Europe, selecting from 25 to 500 years of return time. By clicking on the country, the user can explore more detailed information. This view is available for current analysis, but also for future scenarios. The interactive map will show how climate change will affect the severity of rain intensity and the percentage variation with respect to the present. For the high-resolution view, the map can show data for the selected area with a maximum resolution of 300 meters. Also for this view, the user can explore both present and future scenarios for precipitation intensity variation. Clicking the points on the map, a pop-up box will show details about the selected area. Data is also available for downloading in CSV format to be then easily integrated in other analysis tools if needed.
I'm Eduardo Dueñas, CEO of Metrica 6, and we are the leaders in the consortium for the Metabuilding project called Natural Digibuilding. What we did in this project is that we created several devices and a platform to control these devices and to check how they perform. And those devices are set for having a measurement of how a new refurbishment is efficient regarding the energy efficiency and the energy consumption, and also the water consumption. So what we did was to create this set of devices and platform, like for example, this one that I show you here. This is, well, this one is open. This is for the air quality monitoring outdoors and indoors. As you can see, it works with batteries. Another one of the devices that we have developed here, this one, which I took the electric board. But this one is for the water management or the water control. So here you can see part of the system, which is a valve with with a set of sensors for water flow and for water temperature. And what we did was to communicate all these sensors and all these technologies, which we also researched during the program, and we communicated them with a platform that we also developed during this project. So by the end, what we have is this ecosystem of devices and web app, which is the software part, a web app, and you can check there how all these sensors perform in your installation. So you can have a digital twin of your installation and very focused on the part of the energy efficiency and water usage efficiency. So how these measurements can help you to know more about your installation and how you can improve your efficiency and to have a more sustainable or responsible consumption. So that's the main point of what we did in this project, and now it is up or next to the commercial stage. And what we are doing now is to create this web for promoting the devices, to check with different partners and investors for different smart city projects, and of course private projects related to the smart city, smart home, sustainable construction environment. So if you want to help us, you can already check in our website. You can check for Ysense, which is the name of the water solutions, and you can check also for iMind, which is the other part of the solutions for the air quality control, the temperature, etc. And they work under the same environment that we have already created. So thank you, Metabuilding, for granting us the opportunity to create this project, to learn so much about how to perform this kind of solutions. You also granted us the opportunity to create this collaboration with a transnational or international company, which is Integrated Worlds. They are from Germany, but they work in other countries as well. It has been a really great opportunity for us to create this kind of collaboration, because we know that it's not going to be the last project that we collaborate in. In fact, they have the chance and they have the opportunity to work with us in other Spanish projects, and now we have the opportunity to work with them in other German projects regarding this technology. So thank you very much for your time. Thank you everyone, and enjoy looking at the devices and what we do in our website, and hope to know more about you soon. Thank you very much.
Hello, I'm Fernando Morales, CEO of Being 60 Company. We are presenting Wellbeing Project. The main goal of Wellbeing is to demonstrate the use of digital twins to improve the comfort and indoor air quality of buildings, bringing to users valuable information. The project consists of obtaining measurements of CO2 and other pollutants in the air and ambient data such as temperature, humidity, as well as the automatic detection of people in the room, crossing the data with the BIM model as a reference in order to analyze all the information in real time, and being notified if the values are on warning, and we need to open windows to improve the indoor air quality air index. Our Wing digital twin platform integrated to IoT technology is the key factor in Wellbeing Project. These technologies are the ones we propose to improve interior conditions in the spaces we live and we work in the 90% of time for people living in cities.
you.